Okay, so we're going to look at that same idea that we looked at with the orange, but this time with shapes. This will be more like what you see in class, on any test we may take, and at the very end of the year with our third grade end of grade test that you're all going to kill, no worries. All right, so here we go. Look at number 1. We have this picture and we have 3 different rectangles and some parts of the rectangle shaded in pink. So the first thing that you need to do, I always like to start with trying to figure out what is this bottom number going to be, okay? What's the denominator? So I know we've talked about how denominator is the total number of parts, but this, even when you have more than one shape, this denominator is the total number of parts for each shape. If you have more than one shape in one picture for one problem together, in third grade, they should all be broken into the same amount of total parts. So let's see if we can figure out the denominator for number 1, okay? Here we go. There's 1, 2, 3, 4, 5, 6 total parts in this first rectangle. Fabulous. I'm just going to write a little denominator of 6 to remind me. 1, 2, 3, 4, 5, 6. Okay, this checks out. This guy also is broken into a total of 6 parts. And then our last one. 1, 2, 3, 4, 5, 6. Okay, so it's pretty safe to say that our denominator for number 1 is going to be 6 because every single one of these rectangles is broken into 6 equal parts. Now, if I wanted to know the fraction shaded, I would have to go back and count up all of the pink parts, okay? So I could say there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 parts shaded. So my final fraction is going to be 10/6. Another way to look at this is I know every single piece in this rectangle has the value of 1/6. It's one piece out of a total of 6. So I could count it up with that in mind. I could say 1/6, 2/6, 3/6, 4/6, 5/6, 6/6, 7/6, 8/6, 9/6, 10/6. Gets me the same answer. Now in the other video we talked about how when your numerator is bigger than your denominator, it means that it's more than one whole. It's bigger than one whole. And if you look at the picture, you can see, okay, this whole rectangle is shaded in, the whole thing. So I have one hole, and then I don't just stop at one hole. I also have a couple little extra dudes hanging around, right? So it matches our idea in the orange video too, how that when the numerator or the top number is bigger than the denominator, it means that the fraction is showing you more than just one whole. This shows me a whole rectangle and some extra parts. All right, so let's look at the second one. Let's see what happens when we change the denominator, if it's the same idea. So I have a bunch of trapezoids drawn for number 2. Remember, like I said for number 1, I always like to start with trying to figure out my denominator, the total number of pieces that each shape is broken up into. So here we go. Here's my first trapezoid. It's broken into 1, 2 pieces. So far it's looking like my denominator is going to be 2. Here's my second trapezoid. It's also broken into 1, 2 pieces. The third one is broken into 1, 2 pieces. The fourth one is broken into 1, 2 pieces. So my denominator, my bottom number, the total number of parts that the shape, or maybe the fruit, or the food, or the pizza, or the cake, or whatever is broken into, for this particular example, is 2. Everything's broken into 2 equal parts. My bad, y'all cannot see that. Scooch this dude back. Okie dokie. Here we go, love bug. Let's keep rocking and rolling with this. Okay, so it's a total of 2 equal parts. Everything's broken up into 2 equal parts. Now again, if I wanted to know the fraction shaded, I'm going to go back and I'm going to count how many pieces are shaded. So 1, 2, 3, 4, 5, 6. 6 of these pieces are shaded. just like I did with number 1, I can double check myself. If I say, okay, every shape is broken into 2 equal parts, okay? It represents a half. So let's count it that way. 1 half, 2 halves, 3 halves, 4 halves, 5 halves, 6 halves. That matches the fraction we came up with. So again, we have this whole debacle of what in the world, why is this top number bigger than the bottom number? We haven't been doing this. What in the world is going on? Did I accidentally flip-flop it? Well, in this case, no. Because look, when the top is bigger than the bottom, we know it means there is more than one hole. Is there more than one whole trapezoid colored in for number 2? Yeah, look. This whole dude is colored in. This whole dude is colored in. So that's more than one hole, right? That's 2 whole trapezoids colored in. And then we have these little scragglers hanging around, right? So 1 6, or my bad, y'all. 1 half, 2 halves, 3 halves, 4 halves, 5 halves, 6 halves.